I'm sure you know what these symbols mean. The one on the left is division and the one on the right is a square root. What's interesting is that the two operations have something in common, something you've probably never thought about before. So let's take a look at these two operations and see if we can figure out what they do share. We can think of both operations as requiring us to decompose a number. In other words, break it into smaller pieces, and then compose it again by putting those pieces back together. It's how we break the number apart and how we put it back together that makes the difference between a division and a root. Let's start with the division. When we divide, we need to decompose as a sum. In other words, break our number apart into numbers that, when added together, give us our number back again. We could think of 16 as 16 ones that are added together. Now we'll take those 16 ones and compose them according to what we're dividing by, which is 2. That tells us that we need to divide this into 2 equal groups. Each of those groups contain a sum of 8, and that's why 16 divided by 2 is 8. Decomposing 16 into a bunch of ones isn't the only way we could decompose it. We could also have decomposed it as 8 2's added together. And if we did that, and still divided it into 2 equal groups because we're dividing by 2, each group still contains a sum of 8, which still tells us that 16 divided by 2 is 8. Now let's look at a root, like the square root of 16. We're still going to decompose a 16, but now, because we're taking a root, we're going to decompose it as a product. In other words, we'll rewrite the 16 as numbers which, when multiplied, will give us the 16 back again. To regroup, we'll look at the index in our radical, and since we don't see one, it's understood to be a 2 for our square root. That tells us that we need to take those 4 factors of 2 and divide them into 2 equal groups. Each group contains a product, 2 times 2, which is 4, which tells us that the square root of 16 is 4. We could have decomposed the 16 a little differently to get the same answer, like maybe seeing 16 as 4 times 4. If we divide that into 2 equal groups, because our index was 2, each group contains a 4, which tells us the square root of 16 is still 4. So you can see that both division and roots involve decomposing a number. But with division, we decompose as a sum, and with roots, we decompose as a product. Now let's look at a couple more examples just to make sure we've got this. Let's start with the division problem, 64 divided by 4. We'll take that 64 and decompose it as a bunch of 8s, 8 8's added together. Remember, if we're doing division, we decompose as a sum. Since we're dividing by 4, we will divide that into 4 equal groups. And each group contains 8 plus 8, which is 16. So we know that 64 divided by 4 is 16. Now how about the radical? This one's a cube root, but still we need to take that 64 and break it up as a product. The index is 3, so we'll break those 2's up into 3 equal groups. Each group contains 2 times 2, which is 4. So the cube root of 64 is 4.